Perpendicular bisectors. So just to interpret what a perpendicular bisector is, we know that perpendicular means to be at a right angle, and to bisect means to cut in half. So if we're trying to calculate or find the perpendicular bisector of the interval AB, so here's the interval AB, we're looking at finding a line that bisects AB, so cuts it in half, so we would therefore need to find the midpoint, and that's also perpendicular to AB. So it will need to be at a right angle to AB. So obviously, in order to find the equation of the perpendicular bisector, equation of any line, we need 2 points, or point and a gradient. The point that the perpendicular bisector goes through is going to be the midpoint. The perpendicular bisector, you should note, does not go through point A or point B, so neither of those points are useful in finding the equation of this pink line, the perpendicular bisector. So we'd need to find the midpoint, and we'd also need the gradient. So we can find the gradient because of the fact that the lines are perpendicular. So we can find the gradient of AB, then take the negative reciprocal to find the perpendicular gradient. At that point, we'll then have a point and the gradient, and so we can then go on to calculate the equation of the line. So in this first example, we have 2 points, A and B, and we wish to find the perpendicular bisector of the interval AB. So A has coordinates 7, 0, and B has coordinates 1, 8. So there are a number of steps to finding the equation of the perpendicular bisector, but it's the same every time. We're going to need to find the midpoint of AB, so that we have a point that the perpendicular bisector goes through. So midpoint, we know we average the x coordinates and we average the y coordinates to find that the midpoint has coordinates 4, 4. We're then going to need to work out the gradient of AB, so rise over run, change in the y values over change in the x values, so 8 over negative 6, so negative 4/3. Which then tells us that our perpendicular gradient will be the negative reciprocal of negative 4/3, so it will become positive 3/4. And so now we have our key information for finding the equation of the perpendicular bisector. We have a point that it goes through, and we have the gradient. So this is x1, y1, and this is m. So now we can find the equation of the line y minus y1 equals m x minus x1. So y minus 4 is equal to gradient, which is 3/4 of x minus the x coordinate of the point, which is 4. Expand, simplify. So we're going to have 3/4 x minus 3, adding 4 to both sides. And so we have the equation of the perpendicular bisector. Again, you can use y equals mx plus c instead. Substitute the gradient, substitute the point, solve for c, and put the information back into y equals mx plus c to give your equation. The second example, find the equation of the perpendicular bisector of A and B, where A has coordinates 6, 3, and B has coordinates negative 4, negative 2. So we need midpoint, averaging the x coordinates, 6 plus negative 4 over 2, averaging the y coordinates, 3 plus negative 2 over 2. So we're going to have 2 over 2 and 1 over 2. So midpoint with coordinates of 1, 1/2. So that's going to be a key bit of information for our equation of the perpendicular bisector. Then we also need the gradient of AB. So 3 minus minus 2 over 6 minus minus 4. So that's 3 plus 2, which is 5, over 6 plus 4, which is 10. so 1/2. So that means that our perpendicular gradient will be the negative reciprocal of 1/2. So we're going to get negative 2 over 1, so negative 2. So we now have gradient and point. So y minus y1 equals mx minus x1. So y minus 1/2 is equal to negative 2 x minus 1. Expanding the right hand side, add 1/2 to both sides. So 2 plus 1/2 is 2 1/2, which is 5 on 2. So y is equal to negative 2x plus 5 on 2 is the equation of my line. Again, you could use y equals mx plus c if you prefer that as your method for finding the equation of a line.